Hi everyone, welcome to section 7.3. In the last two sections, we learned about the sampling distributions of the sample mean and the sample proportion. We also learned how to calculate probabilities using each one. In this section, we are going to put everything together. The main challenge isn't learning a new formula. It's deciding which distribution to use before solving the problem. Let's begin. Take a look at this table. If the problem asks about an individual value, use the original random variable x. If it asks about a sample mean or an average, use the sampling distribution of x bar. And if it asks about a proportion, percent, or success rate, use the sampling distribution for p hat. That's really the key idea for this section. This table on the right is a quick formula sheet from section 7.1 and 7.2. Since we have already covered them, we'll simply use them in today's examples instead of reviewing them again. Now let's apply this to our first example. Example 1. A manufacturer produces a commodity where the length of the commodity has approximately normal distribution with a mean of 11.8 inches and standard deviation of 2.8 inches. If a sample of 32 items is chosen at random, what is the probability the sample's mean length is greater than 12.2 inches? Before we start calculating, let's identify the information we're given and what the problem is asking us to find. We have a normal distribution with a population mean of 11.8 inches and population standard deviation is 2.8 inches. The sample size is 32. The question asks for the probability that the sample mean is greater than 12.2 inches. So we're looking for P of X bar greater than 12.2. Since the question is asking for a sample mean, we'll use the sampling distribution of X bar. The problem also tells us the population is approximately normal, so the sampling distribution of the sample mean is also approximately normal. Next, let's find the mean and standard error of the sampling distribution. Mu of X bar equals mu, and mu is 11.8, so mu of X bar is also 11.8. Sigma of X bar equals sigma over square root of n. Sigma is 2.8 and n is 32. So we have 2.8 over square root of 32. Since we are going to use this value again in the calculator, I am going to leave it in this exact form instead of rounding. Trying to round only your final answer. If you round too early, your answer may be slightly different and you could lose points. Now, let's sketch the sampling distribution. The value on this horizontal line is X bar, which is the sample mean. The mean 11.8 is at the center of the curve. We want to find the probability that X bar is greater than 12.2. So we want to place 12.2 on the graph as well. 12.2 is to the right of the mean. Since we're finding the probability that X bar is greater than 12.2, we want the area to the right of 12.2. So this area represents the probability that X bar is greater than 12.2. To find this probability, we'll use normal CDF on the calculator. So we have probability of X bar is greater than 12.2 equals normal CDF. Remember that normal CDF always takes 4 values. The first one is the lower bound. The second one is the upper bound. The third one is the mean. And the last one is the standard deviation. So for this problem, the lower bound of this area is 12.2. The upper bound is infinity, so we'll use 10 to the 99th. The mean is 11.8. And the standard deviation is the standard error, which is 2.8 over square root of 32. Now, let's enter this in the calculator. Press second vars to open the distribution menu. Choose normal CDF and press enter. For the lower bound, enter 12.2. For the upper bound, enter 10 to the 99th. For the mean, enter 11.8. For the standard deviation, enter 2.8 over square root of 32. To type the square root, press second and then x squared and enter 32. Now highlight paste and press enter. Check if the command on the screen matches the one you have on paper and then press enter. This is our answer. The calculator gives 0.2095101037. Rounding to 4 decimal places, and we get 0.2095. So there is approximately 20.95% chance that a random sample of 32 items will have an average length greater than 12.2 inches. Notice that because this problem asks about a sample mean, we use the sampling distribution of X bar, not the original population distribution.